In this class we're going to be concerned with sampling and bias. Now, surveys may be inaccurate because of bias. This may come about because of the way in which, let's say, interviews are conducted, or the way questions in a questionnaire are worded. So there are many ways in which bias can arise. One form of bias relates to the sample selection. Now, this may be caused by a non-random sampling method. Random sampling means every member of the population has an equal chance of being selected. If there are 100 items in the sample, then the chance of anyone being selected should be 1 over 100, 1/100th. If it's not the case, there is bias. So random sampling means every element in the population has an equal chance of selection. With non-random sampling methods, these are cheaper to use. They're more convenient. It means the sample is selected by asking friends. Or it may be just standing on the street and stopping people, or trying to find respondents in the most convenient form. But that's not random. And that means that the results will be biased in various ways. A mismatch between the target population and the sampling frame available. That is the essence of the bias. When there is a significant difference between the results from the sample and what is actually the case within the population. So let's say the sample had a mean of 10, but we knew, or we know, that the population has a mean of 20. Now clearly the sample is way off. It's 10, and the population, the true mean of the population, is 20. Something has gone wrong in the sampling procedure. It's biased. It was perhaps the sample was not large enough, or perhaps it was selected in the wrong way. It could be caused by a lack of response from some of the chosen sample. People sometimes don't want to respond to questionnaires or to surveys. They haven't got time, they're not interested, or they're worried about security. They're worried about what's going to happen to the information. And sometimes it might be difficult to contact people. You see, if the sample is randomly selected, this may mean the people conducting the survey know who they need to interview, let's say. They have identified the people, they've identified where they live. But where they live may be geographically very far apart. So it's very expensive. It's very, very difficult to conduct a random sample in many cases. Which means that many people are not contacted. That introduces bias. They should be contacted. That's if the sample is to reflect the population, the sample must be completed. Those selected must be interviewed, or the information selected in the manner in which it's set out, or it should be set out. But it may be the case, of course, having randomly selected and found every element in the sample, every respondent in the sample, some people simply don't want to take part. They're worried about what's going to happen to the information, or they haven't got time, or they're not interested. Again, that will introduce bias. Let's talk about random sampling, because everything seems to relate to random sampling, and random sampling seems to be the perfect way in which samples are worked out. Now, as I said earlier, a random sample gives every member of a population an equal chance of being selected. So if there are 100 in the population, 100 elements in the population, then every element should have an equal chance of being selected. In other words, the probability of any one element being selected should be 1 over 100, 100th. In fact, the probabilities do not necessarily have to be equal, but the selection method must be objective. Now, that's a slightly more sophisticated point, because sometimes within the random sample, within the population, elements have particular characteristics which make them more important than others. If that's the case, then the probabilities may be not equal. It may be important to question some people more than others to get an overall view, simply because some of the elements within the population, some of the respondents within the population are more important than others. Random sampling is sometimes referred to as probability sampling, so you'll see it as probability sampling in many articles. It's just random sampling. To minimize selection bias, a sample must be chosen so as to incorporate the key features of the random sample. In other words, the key features of random sampling should be applied. The elements of the population should be selected objectively. They should not be selected through personal bias or personal preference. They should be selected objectively. If there are 100 elements in the population, then if all of the elements are equally important, then they should have 100th chance of being selected. Each one should have the same probability of being selected. And there are ways in which this can happen. In fact, let's move to talking about choosing a simple random sample. Now, there are three approaches. First is a physical approach. Assign a number to each element in the population and then hold a draw. So imagine we have a population of 100 elements, 100, say, respondents. When we want to draw a random sample out of this, give each element a number. So each element or each respondent is identified by a number. Write the number on a piece of paper. I'm being very simple here, but let's say just write it on a piece of paper. So now we have 100 pieces of paper, each one with a number, and each number corresponds to a member of the population. Now put the 100 pieces of paper into a bag, shake it up, and draw out 10. Now if it's unbiased, if all the paper is the same and if there's been no cheating, then every element in the population had an equal chance of being selected and 10 were picked. So that's the idea of the physical approach. It could be a computer-generated sample. Computers can be used to generate random numbers. Programs enable researchers to enter population data and then select a simple sample selected randomly. However, computers don't actually use random numbers. They use what's known as pseudo-random numbers. They're not truly random. Computer games are all based on pseudo-random numbers. The computer must constantly compute random numbers and to make the game more interesting, to make the game seem realistic. But they're not true random numbers. Random numbers are the way we've just described in the physical approach, drawing pieces of paper out of a hat or out of a bag and each element then truly has the same probability of being selected. Computers can't do that. They can't have that physical approach. So what computers do is they start with a number, and that number is given to the program, if you like, in some particular way. And then it follows an algorithm. It calculates. It takes the number, let's say it's a 4-digit number, and the algorithm says cube the number and then do something else. Take the square root of what we've got and then cube it again, and then take 4 numbers starting 2 numbers from the right. So there's some rule that the computer has worked out, or that has been given to the computer. Programmers have inserted some rule so that the next 4 numbers that come out look random, but in fact they've been calculated following some algorithm, some procedure, some mathematical procedure. And of course, once the second 4 numbers are selected, the rule is applied to them again, and so on and so on. If we continue to do it, if we continue to run the game a very large number of times, some people think we would have to run it for hundreds of years, but if we did, we would get back to the 4 original numbers. So it will cycle. But for most practical purposes, randomly generated computer numbers, these are good enough for us. The error that would be involved in using computers over and above the physical approach, that error is very small. So generally speaking, using computers is a way forward. But I'm just saying that it's not truly random, it's pseudo-random. Computers use pseudo-random numbers, they're not true random numbers. There is another way, using random number tables. Now this may be a surprise to many of you, but it's possible to get tables which are random numbers. It's possible to buy these in shops that sell mathematical material. So a random number table is just looks like a jumble of numbers. In fact, all of these numbers have been carefully selected randomly. So they are random numbers. They are special numbers, carefully selected, perhaps drawn out of the hat, like I've suggested before. So if we look at a set of random number tables, we'll see how it works. Let's take here's a table from one table from a set of random number tables. Now, as you can see, it just looks like a jumble of numbers. I'll just put the cursor onto the screen for a second. There, I've identified we would start with this one. We don't have to start there. You could start anywhere. You could start over here, for example, or anywhere you want. Why we would start there? Well, ideally that should have been randomly selected as well. So we could say, well, hang on a second, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10. It looks like 10 columns. 2, 4, 6, 8, 10. Yeah, 10 columns, and we have so many rows down. We can count the rows down. So now we can identify, randomly select 1 to 10. That'll give us which column we're on, and then randomly select the number of rows, so we know which row we're on. So if we know the number of the column and the number of the row, we would have our starting random number, which could be this one here. Okay, so now we've got a random number table, which are properly produced. These are proper random numbers that have been supplied by people who have calculated them. And we've selected a starting point. And we've selected the starting point, let's say we've selected it randomly. We haven't selected it because we simply like that number. We have selected it because it was random. Now, assume that we want to select 10 elements from a population of 70. So we want to select 10. So what we need now are 10 random numbers. We start where we have selected, and let's say we select the first 2 digits. We could select the last 2 digits, or the 2 digits starting 1 in from the left, or the 2 digits ending 1 in from the right, or whatever. But let's say we just select the first 2 digits. We're trying to make it easy here, so take the first 2 digits. You can take any 2 digits. Now, if we work across, because we have set out a rule before we started, if we work across, we'll see that the first 2 digits are 0, 6, so the first one is 6. The next 2 is 3, 7. That's 37. Then we have 55, 71, 83, 46, 74, and so on. So what we've got then is we've picked our random numbers off the random number table. The first number is 6, the second one is 37, the second one is 55, so the second one here is 37, and 55, 71, 83, and these are random numbers. So what we would do then is identify the elements in the population by number and go and interview, let's say, the 6th person. Then we'd interview the 37th person, and so on. And when we've got our number worked out, we've completed the 10 that we needed, or the 20, or whatever the size of sample we wanted, it would be complete. And we've used random number tables to do this. Let's look at simple random sampling. In this case, every possible subset of the population has an equal chance of being selected. That's what we mean by simple random sampling. Now, the sampling may be with replacement or without. If the population is small, and when we sample, we want to let's be sure that we don't interview the same person twice. So we would take that person out. So if the population was small, then the population is getting smaller because we're taking people out. We've interviewed them so that they can't be interviewed twice, so they're now removed from the population, the available population that's left. So the population size will be changing, and this will influence our calculations. The population size is changing. If it's a very large population, then if we take the person out, we've interviewed a certain person, we want to make sure we don't interview that person again, so we take them out of the population. The population would not diminish an awful lot. So taking a person out of the population will not affect the size of the population significantly if the population is large. Now let's talk about systematic sampling. This approach is easier to do as compared with simple random sampling. This approach is quite straightforward. If a sample population has n members, so there are n people in the population, let's say there's 100 or there's 500, whatever. So we have n members in a population, and we want a sample size of x. So we want a sample size of 10, and this sample size is required. Then case samples must be made, and how we work that out is simple. We just say we take the number of the population, n, and the sample size is x. So we have a certain sample size. If we have the population is 100 and the sample is 10, then we divide 100 by 10, which means we would need 10 samples. Now select a starting point, select a member of the population randomly. Next, select every 10th item, let's say. Select whatever this little formula gives us. Select every, say, 10th item. So we select, let's say the population is 100 and the sample size has to be 10. So we would have k samples. We'd have 10 samples, 10 in the sample. So we would select the first one randomly in the population, and then we take every 10th person after that. And this is systematic sampling. We have to find one person randomly, and then we take every 10th along. Now this is used quite extensively. It could be used, for example, when surveying a particular location. Instead of having to travel all over the location, one street could be selected. That street could be selected randomly. And then we'd select a house on the street, select that house randomly, and then perhaps select every 4th house. Now that makes sampling cheaper. It's not as precise as random sampling, but it's still quite systematic. It's still pretty good. So it's a cheap and effective way of getting a good sample, providing the population does not have sequential regularities. And that is the problem. If the population has got some quirk where it's following some pattern, it may be that systematic sampling leads to very wrong solutions. Go back to the location one. If the whole location has a certain feeling, let's say it's an attitudinal survey about the economy, and the whole area is quite depressed, but on one street they've just won the lottery and everybody in the street had a share in it. They all pooled together to buy the ticket. Now that street's going to feel very happy. All the rest of the area is depressed, and just bad luck, that street was selected, and a house on that street was randomly selected, and then every 4th house, let's say, was selected. Well, every 4th house is going to be happy as well. So it may be the case that the researcher comes away thinking everybody in this area is happy. In fact, the vast majority of the people are quite depressed. It was just bad luck. Now we've got stratified sampling, slightly different. This divides the population into groups or into strata. Each stratum shares the characteristics that are the subject of the survey. The sampling for most surveys include an element of stratification. So sampling for most surveys has got some degree of stratification. This involves dividing up the population into groups or strata on the basis of some criterion relevant to the subject of the survey. A random sample from each stratum is then selected. So stratified sampling ensures that different groups, for example, may be included in the survey, and that their opinions may be included in the survey. So it could be based on gender, male, female, so many male, so many female. So X% of the population should be male, Y% female, or 50-50. Now within each of these strata there may be an age dimension. So a certain number of people have to be over 50, certain number of people have to be over 30, some over 20, and so on. So we've got different strata in there. So now we're picking up males at certain ages and females at certain ages. So we are covering lots of possibilities. And that's the idea of stratified sampling. The advantage of this approach, or the advantages, are the sample is guaranteed to be representative of the population. So this guarantees that different opinions and different types of respondent are included. As I said, 50-50, male, female, or it could be done on the basis of race, or it could be done on gender, or it could be done on age. It could be done by location. A certain number of people live in London and a certain number of people don't live in London. So it's, again, it's stratified. So now the researcher knows that this sample that's been selected represents those various groups. Whereas if it was a simple random sample, it is possible, if the population is sampled randomly, that all the respondents selected are all female, or all the respondents selected are all male. That's possible. But with stratified, it's going to be, say, 50-50, or whatever the researcher chooses the proportion to be. So the sample may be more representative. And it's also possible to, of course, publish the results for each strata. It's possible when the analysis is done to say overall people are feeling optimistic about the economic situation the country is in. However, males are more optimistic and females are less optimistic, and people over 50 feel this and people over 30 feel that, and so on. So it's possible to get more information out of the stratified sample. And also different sampling procedures may be appropriate for different strata. Ideally, it should be done randomly. We keep saying this, but that is the way in which a more representative sample is drawn up. But it may be that different sampling procedures are used. It may be possible, for example, to pick up some information by questionnaire, some by interview. It may be that certain areas are looked at, say one particular street is interviewed and it's contrasted with a different street someplace else, and it's possible to mix it up. But the point is that the strata overall should represent the characteristics of the overall population in terms of, let's say, gender divide, age, race, religion, whatever is being looked at. It is easier to administer the survey. Each stratum may have its own dedicated researchers. It may be that expert researchers are used to pick up the particular information from strata, so that it's a much more accurate representation of the population. So in this class we've looked at different types of sampling, and we've looked at sampling bias. Very important topics, and very important to bear these in mind. A lot of information that business uses, and also of course sociologists and the government and even academics use, is collected through sample surveys. It's important to be aware of the different types of sample surveys that may be used: systematic, simple random sampling, stratified, and there are many others that we will come across in the other classes in this area. And there'll be videos on those for you to see. But for the moment, we've identified some important ones here, and we've talked about the problem of bias. And that's all I'm going to do in this session, so I'm going to leave it at that and say thank you for watching.